Welcome back, everyone. I am absolutely thrilled you're joining me for this explainer today because we are looking at something that is fundamentally shifting how we think about software development. Now, if you've ever felt like pulling your hair out from copying and pasting code back and forth with a standard AI chatbot, you're definitely going to want to pay close attention to this. We're diving into a fascinating open source project called OmniAgent. And let me be clear, right out of the gate, this isn't just another chatbot. OmniAgent is designed to be a fully collaborative autonomous AI engineering team. It's a powerful orchestration platform that essentially transforms artificial intelligence from a passive tool into a proactive, virtual software agency. Here's our quick roadmap for the explainer today. First, we'll look beyond simple AI chatbots. Second, we'll meet your new AI engineering team. Third, we'll walk through the autonomous workflow. Fourth, we'll cover self-healing and persistent memory. And finally, number 5, we'll discuss the future of AI development.
All right, Section 1, Beyond Simple AI Chatbots, from single prompts to autonomous systems. Let's dive right in. To really grasp why OmniAgent is such a massive deal, we kind of have to look at the frustrating limits of the old paradigm. You know the drill, right? You ask a question, you get an answer. And if there's an error in the code, it spits out, well, you prompt it again and just cross your fingers. The new paradigm changes the game entirely. We are moving into the era of autonomous systems, collaborative agents, self-correcting workflows, and long-running reasoning. It's literally the difference between having a super smart dictionary sitting on your desk versus having an actual dedicated employee who can reason through a complex problem over time and doesn't even need a coffee break. This shift is absolutely revolutionary. So what's actually making this new paradigm possible? The magic word here is LangGraph. LangGraph is the core orchestration technology driving OmniAgent, and what it does is allow for something called stateful workflows. That just means the system holds on to the context, the state, of the project as it moves along. Unlike a traditional, rigid, linear pipeline, LangGraph allows for multi-agent collaboration, retry routing, and what they call cyclic repair loops. In plain English, it lets the AI loop back on its own work, pause, branch out to do some research, and recover from failures, much like your own brain does when you're trying to solve a tough problem. Moving right along to Section 2, Meet Your AI Engineering Team, a virtual software agency. Think of OmniAgent less like a single piece of software and a lot more like an entire virtual agency. Just like a real-world agency, the heavy lifting is divided up among specialized roles. First up, you've got the planner agent, whose entire job is to take your big, ambitious goal and break it down into manageable tasks. Then the research agent takes over, actively scouring the web, documentation, and repos to find the best implementation references. Next, the coding agent rolls up its sleeves to generate the files, write the logic, and create tests. But wait, it doesn't stop there. The execution agent actually takes that code and runs it. After that, the critic agent steps in. Think of this as your grumpy senior developer, reviewing the outputs for code quality, hallucinations, and security vulnerabilities. And finally, the memory agent acts as the team historian, storing long-term knowledge. It is a brilliant divide-and-conquer strategy executed 100% by AI.
Okay, Section 3, the autonomous workflow, from inception to execution.
Let's walk through a day in the life of this AI team so you can see exactly how a request travels through this whole graph-based system. Step 1 starts with a simple user request. You provide the overarching goal. Step 2 is the planning phase, where the planner agent locks in an execution strategy. By Step 3, the research phase kicks into high gear to check APIs and pull best practices. Step 4 brings us to code generation, drafting the actual project structure and logic. And then, crucially, we hit Step 5, execution. The system doesn't just hand you a text file and say, good luck, it actually runs the code. And what's incredibly vital here is that it runs it inside a secure Docker sandbox environment. That means it captures logs and errors safely without ever putting your local machine at risk. Let's see how the second half of this workflow builds, because this is where the real magic happens. Step 6 is the self-healing loop. If that execution in Step 5 fails, the agent doesn't panic. It automatically attempts to fix its own bugs. Step 7 brings in that critical review we talked about, double-checking for architectural soundness and security flaws. Step 8 introduces a forced pause for human approval on high-risk actions, which we'll dive deeper into in just a sec. And finally, Step 9 is final delivery. But it returns way more than just source code. You get documentation, architecture reports, and execution logs. It's an incredibly thorough, highly professional handover. Section 4, Self-Healing and Persistent Memory. How the system learns and adapts. The system's persistent memory is absolutely crucial here. It retains a massive amount of context. We're talking previous tasks, your specific coding patterns, successful fixes from past errors, user preferences, and full execution histories. The memory agent is basically the long-term brain of the entire operation. So why does this matter for you? Well, it means the system actually gets smarter and more aligned with your specific way of working over time. If it figures out a complex bug fix on a Tuesday, there's no way it's making that same mistake on Thursday. It learns and it adapts.
Now, with all this autonomy, you might be wondering, is this safe? Safety is paramount here, and that's exactly why high-risk actions immediately pause execution until they are approved. This is known as the human-in-the-loop safety net. While the AI is totally free to research, code, and debug in its sandbox, if it tries to do something major, like deploy to production, delete critical files, make expensive API calls, or drop a database, it triggers an interrupt. The workflow literally stops in its tracks and waits for your explicit sign-off. You remain the ultimate authority, making this a highly secure, production-ready design.
And finally, Section 5, the future of AI development, the tech stack and beyond.
Let's take a super quick peek under the hood, because the OmniAgent tech stack is robust and incredibly modern. You've got LangGraph handling all the complex orchestration. For the large language models, the actual brains of the agents, it seamlessly supports OpenAI, Grook, and Gemini. The backend is running on FastAPI, all execution is sandboxed safely in Docker, memory is managed via ChromaDB as a vector database, and LangSmith handles the observability, so you can actually monitor the AI's decision-making process in real time. Make no mistake, this is not a weekend toy script. This is a production-grade technology stack built for serious automation.
Which leaves us with the project's incredibly powerful end goal, a fully autonomous AI system capable of handling the entire software lifecycle with minimal human intervention. Just imagine having a tireless, autonomous engineering team right at your fingertips, knocking out complex projects while you get to focus purely on high-level strategy and creativity. The shift from simple chatbots to autonomous agencies isn't years away. It's already here. So the question isn't whether AI is going to write code anymore. The real question is, what incredible things are you going to build when you no longer have to? Thank you so much for joining me for this explainer. Keep learning, keep building, and I will see you in the next one.